All right, folks, so if this is your first lesson in a long time, then welcome back. We're looking here at starting our trigonometry 2 units to finish before the end of the semester. Now, we're going to start off with a new way of measuring angles. By the end of this course, I certainly hope you are more comfortable measuring angles in radians than you are measuring in degrees, despite the fact that you have been measuring angles in degrees for a number of years now. Now we'll jump right in, 6.1 radian measure. Tomorrow in section 6.2, I'll post that video tomorrow. Then we'll go over a little bit of the grade 11 review using radians to do so. All right, so we're familiar measuring angles in degrees. We can also measure our angles in what we call radians. Radians are unitless, and you'll see what I mean by that in a moment. But a radian is simply an angle given by the ratio of arc length to radius. So we can ask ourselves, okay, what is arc length? What does that mean? We haven't been using that in here. We haven't really been using angles too much in this course yet. Arc length is the length along the arc of a circle, of a curve. So in this case here, the arc length would be from A to C. All right, so the arc length, we might call that A for arc length. And then the radius, well, we've been working with really the plural of radius is radii. We've been working with those for a very long time. That's the distance from the center of a circle to the outside, right? So the radius can be given by r. So the arc length is given by A divided by r. All right, and that equals theta. So let's take a look. Okay, so we know that one complete revolution of a circle is 360 degrees. We need to ask ourselves, how many radians is 360 degrees? Well, we can figure this out nice and easily because radians are our angle measured, angle theta, measured in radians, is equal to the arc length. So 360 degrees. The arc length of 360 degrees is the length all the way around the circumference of a circle. Well, the equation for circumference of a circle is 2 pi r. All right, so if I'm working with arc length divided by radius, then I need to take 2 pi r, that's the arc length, and divide that by radius. And I can see pretty quickly that this would simplify. I could cancel out my r's. This simplifies to theta equals 2 pi. And that means 2 pi in radians equals 360 degrees. That is the relationship between radians and degrees. Now you might be tempted at this point, you might say, okay, these radians are a little bit weird. I've been working with degrees, I feel more comfortable with degrees, so I would rather work with degrees throughout this entire chapter and just convert it into radians whenever Mr. Prasatka asks me to give an answer in radians. Well, number one, we are going to be working in radians all the time, so you need to do that every single time. Number two, you will, like I said, you will become more comfortable working in radians than you have been working in degrees. So I encourage you to try and embrace that as quickly as you can. You will be working in radians when you get into calculus. Then you'll be working in radians when you get into post-secondary education if you continue to take math courses. All right, so let's say we have this relationship here, and we do, and we can try and simplify it a little bit further. Okay, if 2 pi radians, right, this is in radians, if 2 pi equals 360 degrees, I could divide both of those by by 2 to find that pi radians equals 180 degrees. All right? We can use either of these to convert if we're converting from degrees to radians or radians to degrees. So let's look even further. All right, we'll evaluate this time 90 degrees in radians. Well, if I know that pi equals 180 degrees, and I need to evaluate 90 degrees in radians, I'll pause here for 5 seconds as you try and solving it on your own. It should be nice and straightforward. We can divide both sides. I don't know if that was 5 seconds. We can divide both sides by 2. Maybe I'll write this in another color. We can divide both sides by 2 to find 90 degrees on the right-hand side. And we want to leave this in its exact form. We'll leave it as pi over 2 on the left-hand side. So pi over 2 radians equals 90 degrees. Now let's go even further. Okay, what about 45 degrees? Well, I can do this either from my 90-degree work over here or from the same spot as before. Okay, so pi equals 180 degrees. Now, if I'm trying to find 45 degrees on the right-hand side, I need to divide that by 4, right? 180 divided by 2 is 90, divided by 2 again is 45, so that is 180 divided by 4 equals pi over 4. Well, 180 divided by 4, I know how to do that. That equals the 45. That was my goal. 45 degrees equals pi over 4. So now we're going to use these two angles that we've just come up with, right? Where instead of working with 90 degrees, now we're going to work with pi over 2. Instead of working with 45 degrees, now we're going to work with pi over 4. And we want to label some of the angles that we know on our unit circle below. You should have worked with a unit circle in grade 11. We're just going to jump right in. Let's see here. We'll start with the purple angles. All right, so when we're, and again, we'll go over this as review tomorrow, but when we're measuring an angle, we measure from the positive x-axis. That's the axis right here. So we measure counterclockwise. Oops, I just lost my horizontal axis. We measure counterclockwise from here when we're measuring an angle. So 90 degrees would be 90 degrees from here, and that is, instead of 90 degrees like I'm used to writing this, I'm going to write this as pi over 2. Right, so this is pi over 2. Well, if that's pi over 2, I can take it even further. Okay, so pi over 2 is 90 degrees. Then I can do that again. Instead of 180 degrees, I'm going to work with 2 times pi over 2, right? Because I've done it once and then I've done it again. Well, 2 times pi over 2, I know how to cancel that out. I'm working with just pi. And that makes sense because that's a relationship that we found right off the start, is that 180 degrees equals pi. And let's try labeling that a little bit cleaner, equals pi. All right, and then we can keep right on going, right? This is pi over 2. This is 2 pi over 2, which equals pi. This is 3 pi over 2. So I can label that in here. 3 pi over 2. And lastly, all the way around, pi over 2, pi, 3 pi over 2, 2 pi, yes, 2 pi is all the way around. That's equivalent to 360 degrees, just like we found up above. All right, so now we have labeled each of these purple angles using that relationship that pi over 2 equals 90 degrees. Well, we want to go even further. Here we'll we will label the blue angles using the relationship that pi over 4 equals 45 degrees. Oops, I apologize about the zoom. Like always, pi over 4 equals 45 degrees. That is what we're going to use here. I'll try and find a better size to work with. There we go. So this blue angle is half of this big angle, and that is, this blue angle is 45 degrees, and 45 degrees I know equals pi over 4. And then if I wanted to, I could add this pi over 4 again, and I would come up to this pi over 2, right? 2 times pi over 4, that is 2 times 45 degrees equals 90 degrees. 2 times pi over 4 equals pi over 2. And then I can go even further. Okay, so another 45 degrees. Well, that is pi over 2 plus pi over 4, because that's my other 45 degrees. So if I just work with my fractions here, I see that I'm working with 3 pi over 4. You can pause it there and confirm that if you would like. I'm working with here 3 pi over 4. Okay, adding another pi over 4 brings me to 180 degrees. That brings me to pi radians. Okay, adding another pi over 4 to my next blue angle. Another pi over 4 added to pi, well, that equals 5 pi over 4. And another pi over 4 to that. Remember, pi over 4 is 45 degrees, so adding 45 degrees to that would normally bring me to 270 degrees. But I'm not working in degrees, I'm working with radians. So 5 pi over 4 plus another pi over 4, and that's, geez, I apologize for this zoom, folks. So this is like I'm adding pi over 4. Okay, well, adding pi over 4 to that brings me to 3 pi over 2. It brings me to 6 pi over 4, which reduces to 3 pi over 2. And then I can add another pi over 4 to 3 pi over 2. And I should be working with 7 pi over 4. and then adding another pi over 4 is 8 pi over 4, which equals 2 pi, you guessed it, all the way around. So now those angles that we just took are measurements of 45 degrees, or multiples of 45 degrees, or multiples of pi over 4, now that we're working in radians. All right, now we'll take a tiny bit of a break, and then we'll come back to this unit circle here. We'll try the same thing. This above relationship that we were working with, that is pi equals 180 degrees, we want to use this to evaluate 60 degrees in radians. Okay, well, if pi equals 180 degrees, then I can divide 180 by 3 in order to find that 60 degrees that I'm looking for. Well, pi over 3 cannot be reduced any further. It's that easy. We're working with 60 degrees on the right, pi over 3 on the left. We'll try that again for 30 degrees. I encourage you, I'll pause the video here, try it. In about 2 seconds, it's going to continue to the final answer. And I'm hoping you got it right. Pi over 6 equals 30 degrees. And then we want to use these to write out our new angles. We'll write these ones in red of our unit circle up above. All right, so we're working with pi over 6 here. And you know what? This time I might encourage you to... I'll go right along with you. So pi over 6 is the first one. And then we're going to go another pi over 6. And that is, we're going from, this was 30 degrees, right? So if we do another pi over 6, another 30 degrees, that equals, sorry, just trying to erase what's in the middle here. That equals 60 degrees, right? I'm going even further. Well, 60 degrees, that equals pi over 3 as we calculated down below. And we could consider that as 2 times this pi over 6 that we were working with. That equals pi over 3. Fantastic. Now, if we add in another pi over 6, whoops, sorry, folks. We're adding in another 30 degrees to this pi over 3 up here, which we know equals 60 degrees. Right, so we add pi over 6, or we add 30 degrees to that. So we're working with pi over 3 plus pi over 6. And the analogous to this is 60 degrees plus 30 degrees. So you can see what we're working with in degrees. We know we're expecting the equivalent of 90 degrees. Well, pi over 3, that equals 2 pi over 6 plus a single pi over 6. Now we have a common denominator, so we're working with 3 pi over 6. Sorry, folks, my monitor seems to be unbalanced. I'm sure you can hear some rattling in the background here. 3 pi over 6, that equals pi over 2. Well, pi over 2, fantastic. That's what we were expecting. That is the 90 degrees in radians. So we'll keep right on going. We'll add another 30 degrees, and that is another pi over 6. Okay, so we're working with pi over 2. That's our 90 degrees here. Plus pi over 6. All we're doing is adding up our fractions down here. And in order to... You know what? Maybe I'll leave that there. We're just adding up our fractions over here. What we're doing is we're adding another pi over 6 degrees to find this angle in radians. Right? Sorry, pi over 6 radians, not degrees. So pi over 2 plus pi over 6, well, that equals 3 pi over 6 plus pi over 6, and that equals 4 pi over 6. Well, that reduces to 2 pi over 3. So I'm working here with 2 pi over 3. And I can keep right on going. And folks, what I encourage you to do is keep right on going on your own. I'll post the final, I'll encourage you to pause the video here and then try and fill in the rest of these red angles in radians. Unpause it to check your final work. And let's see how you did. We're working with 7 pi over 6 here, 4 pi over 3, 5 pi over 3, and 11 pi over 6. So this is our unit circle filled in as we're working here in radians, right? You are used to seeing each of these angles. You have worked with each of these angles before. We will go over, we'll review tomorrow how these are derived from our special triangles, how we can find a little bit more exact information about them as we work in radians here. We'll get there tomorrow. Okay, but we will be working with this unit circle throughout this entire chapter. All right, now let's keep right on moving forward. And we'll look, this really could have been called example 2, or example 1, but looks like it wasn't, and that's okay. So we'll take a look. Okay, so we'll use this same relationship, and that is pi radians equals 180 degrees. And we'll try and find out, okay, well then what is the number of degrees of 1 radian? Take a moment here. We can hear our puppy getting ready to bark, so we'll see if she can keep it quiet as I keep moving here. We see this relationship. We have how many radians? Pi radians. Pi, well, that's 3.1415926. I'm not sure how the next digits. That's the number of radians that we're working with, and we need just 1. Okay, so what we need to divide by here is pi, right? Pi divided by pi equals 1. If I divide the left by pi, I can divide the right by pi. I can throw that into my calculator if I would like, and I find that 1 radian, and I can write this as 1, but really it's in radians. 1 radian equals 180 divided by 3.1415926, and really what we end up looking at is that 1 radian equals approximately 57.3 degrees. Okay, 1 radian equals 57.3 degrees. What does this mean geometrically? Let's consider back to this sketch with arc length. Remember, a radian, degrees in radians, is equal to a ratio between arc length and radius. Okay, between arc length and radius. So if we're working with 1 radian, and it equals the arc length divided by the radius, we could rearrange this. We don't necessarily need this radian in here. Working with 1 equals the arc length divided by the radius. We could rearrange this to see that the radius equals the arc length. So where we're working with 1 radian is where we're working where the radius equals the arc length. And that means, as we work, and let's just draw a quick sketch right here. We have our circle there. That means the distance of 1 radius, which is something like this, is equivalent to the length around here, 57-ish degrees, 57.3 degrees. These two lengths are equal, the arc length around and the radius here that we're working with. All right, that's just a fun little tidbit. Now, when we're working with radians, as you may have noticed already, we prefer to express these in their exact form. That means we're giving them in terms of pi. That means we're giving them as fractions. Okay, that's why we were working on our unit circle with 5 pi over 4 instead of 1.25 pi. Right here. If we wanted to throw that into my calculator, I would find that equals 1.25 pi, and I could even throw that into my calculator and find that equals something like 4.2-ish. But we don't want to. We want to work in exact values, and that is with fractions in terms of pi. All right, so we'll keep going a little bit here. Now, we have these angles in degrees. We want to convert them into radians. All right, when we're doing so, we are giving our answers in exact form. Okay, so if we're working with 15 degrees, we know that we want to convert this to radians. And if we're converting it to radians, then we need to multiply it, just like if you're converting any units in physics, in other science classes, or in math classes. If we are, or in real life, if we're converting units, then we want to multiply it by a fancy version of 1. All right, so our fancy version of 1 here will be the number of radians that equal 180 degrees, right? So pi radians equals 180 degrees. So since they are equal, then this is a fancy version of 1. That is 1 over 1. All right, so pi over 180 degrees. And then we can reduce this if we would like. 180 divided by 15. You could try that out. Pause the video if you would like. As I change my color. 180 divided by 15, we are working with right here 12. So that is pi over 12 equals the 15 degrees that we began with. All right, now if we did throw that into our calculator, which we're not necessarily going to, then that works out to around 0.26, and it keeps on going, radians. All right, but we don't care about that. We just care about it in a fraction. Okay, we care about it in its exact form. Now try it out. You should be able to handle the same kind of a conversion from 250 degrees and negative 320 degrees, and you will see the final answers uploaded on the classroom by the time this video is there. So pause the video, try that out, and when you're finished, then we're working on example 2. All right, so here we want to convert them in the other direction. We're working from radians to degrees. Okay, so if we're working with 3 pi over 8, again, since we're converting something, we want to multiply it by a fancy version of 1, and that is it's going to be 1 over 1. Well, what kind of a 1 over 1? In this case, I want to find two things that are equal. Again, last time, we knew that pi equals 180 degrees. That's still true right here, but it's going to be more useful to us if we can find our final answer in degrees. So here we're working this time with 180 degrees in our numerator, 180 degrees divided by pi radians, and we can work forward here. Okay, so we can simplify this. Our pi's cancel out. Our pi's cancel out. 180 degrees divided by 8 multiplied by 3. What we're working with here is, we can, I paused there as I was trying to work it through so you don't hear me working through it. That is 180 degrees. Well, we can simplify this a little bit further. 180 degrees times 3 divided by 8. Well, 180 degrees, I can divide that by 2. I can divide 8 by 2, so I'm working with 90 degrees times 3 divided by 4. I can simplify that further. Half of 90 degrees equals 45 degrees times 3 divided by 4. And we can leave it there if we would like. All right, 45 degrees times 3 divided by 4, and then we can throw that into our calculator, or you can try and work it through in your mind. That's completely fine too. We're working with 67.5 degrees. You'll notice as we convert from exact values to degrees, we're more likely to be using our calculator. All right, now I want you to try a similar process over here. That is negative 2 pi divided by 5. If you did, and I'm hoping you checked your answers up here for 1, B, and C on the classroom, and assuming you answered those correctly, then it should be nice and straightforward to answer 2B and 2C. So try them out there. Pause the video and check your answers on the classroom, and then come back. And sorry, you know what? I'm hoping you didn't pause the video and come back, because that's the end of this note. So at that point, this point, you can work through the practice problems, and then you should be ready to handle section 6.2 next.